Integration can be challenging, and this is a challenging problem. So we'll do one hard case together, and so you can get kind of a flavor of some of the challenges that you're going to come across if you want to do further studies in using this technique. So with this problem, you can kind of see we've got an x cubed here and an x squared there, so it does sort of look like one is the derivative of the other, but there's still a lot more going on that makes it harder to see compared to the very first example we did. So why don't I let u be equal to the square root of 1 plus x squared. Let u be equal to 1 plus x squared. Now I'll write the integral x cubed u dx. Now we've got to find the derivative of u over dx. And if we do that, we're going to get something really kind of ugly. And it's going to be really hard to work with this. So why don't we do something else? Why don't we get rid of this altogether? And what we could do instead is square both sides of this expression. So we have u squared is equal to 1 plus x squared. And now I'm going to take the derivative of this thing with respect to x. And I'm going to take the derivative of both sides to be explicit about it. And I want you to remember from chapter 7 that u is an implicit function of x. Now when I take the derivative of this, I'm going to get 2u times du dx. Right? That's my implicit derivative. And it's going to be equal to the right-hand side, which is just 2x. And that looks a lot easier on my eyes than that thing that I derived earlier. And I can simplify this. I can write it as u du dx is equal to x. And u du is equal to x dx. And that looks like something I might be able to use. So remember, what's our next step? Well, we've got this integral with u in it. And so if I just rewrite this thing, I've got it like that, but I could factor out one of the x's from the x cubed, and now notice we've got x dx and x dx. When I make that substitution, I'm going to have x squared u du. So I've got x squared u squared du. Now I'm getting closer, but I'm not there yet because of course I've got this x squared floating around. But remember what I defined u as. I know that u is equal to, or specifically here, u squared is equal to 1 plus x squared. And that means that x squared is going to be equal to u squared minus 1. And so I can make another substitution. And I'm going to have the integral of u squared minus 1 times u squared du. Now I've gotten rid of those x's. The x's aren't floating around, making it difficult for me to integrate. I got this kind of product on the right hand side, but I can work through, I can open up the bracket and now I've got two power terms, or I should say power functions, and I can take the integral of this thing, and I'm going to get u to the power of 5 over 5 minus u to the power of 3 over 3. And there is my integral with the u's still in it. What happens if I replace the u's? Remember that a u is equal to the square root of 1 plus x squared. All right, let's just double check that. Yep. Square root. Yep, square root of 1 plus x squared. Looks good. So now I'm ready to sub this back in. And maybe I will just do this. I'm going to highlight all this stuff. And then I'm just going to make it a little bit smaller so I can have some more room to work. And subbing in the u's, I'm going to have 1 plus x squared to the square root, or the square root of that, to the power of 5 over 5 minus 1 plus x squared, the square root to the power of 3 over 3. And if I simplify this further, I'm going to get 1 plus x squared to the power of 5 over 2 over 5 minus 1 plus x squared over 3. Now, per usual, I've completely forgotten all my constant terms, so I'm going to add in my constant terms. And now I want to see if I've really got the right answer. Right? Is this the right answer or not? And to find that, I am going to take the derivative of this thing with respect to x. And when I do that, I get 5 over 2 times 1 plus x squared over 5. And that 1 plus x squared is to the power of 3 over 2. Guess I don't need a line there. And what else am I going to do? I am going to take the derivative of the inside. That's going to be 2x. And I've completed the first term. Now I'm moving on to the second term. I've got 3 over 2 times 1 plus x squared, well, the square root of 1 plus x squared over 3 multiplied by 2x. And so we've got 2 divided by 2, 5 divided by 5. We've got 2 divided by 2. We've got 3 divided by 3. So we can rewrite that out. I've got 1 plus x squared to the power of 3 over 2 minus 1 plus x squared, square root of that whole thing. Or maybe to make it clearer, I can write it as to the power of 1/2 and I've got an x there, and I missed an x over here on the left-hand side, so I'll add that in now. So be aware that there's an x here and an x here. Now it still doesn't look like the answer that we started with, so maybe what I'll do is I'm going to factor out a 1 plus x squared. What do we get when we do that? We get 1 plus x squared to the power of 1 times x minus, so we've got an x there, like so. And I'll rewrite my 1 plus x squared, the square root of that. And I've got x plus x squared. I'm multiplying the x into the bracket, minus x. And what's this equal to? It's equal to x cubed square root 1 plus x squared. Is that the right answer? Yes. That's what we started with. Here's a problem for you. Make a great effort. Do your best with this. It's not too difficult, but make sure you identify the u properly. So go ahead, try it. If you get stuck or if you're finished, press play and we'll go through it together. Make sure you can solve it and make sure that you got the right answer. Okay, before we get started, I'm going to try a little bit of simplifying here. So I'm going to write my integral sign there. But notice I've got a 2 and a 4 down in the denominator. So I could write this as the log of x squared plus 2 divided by x plus 4 multiplied by 2. And I could even go a little step further. I could take out that negative 1/2, move it outside the integral since it's a constant. And now I've got log x plus 2 divided by x plus 2. Now looking at what I've got left, I notice I've got an x plus 2, well, it's the log of x plus 2 in the numerator and an x plus 2 in the denominator. And it looks to me like if this is f prime of x, then this thing in the numerator is f of x. And so I'm going to try and let u be equal to f of x. So I'm going to let u be equal to log x plus 2. And if I do that, I'll rewrite my integral as u over x plus 2 dx. I should have had a dx here and a dx over there as well. Now I've got the u here. What's the derivative of u with respect to x? It's 1 over x plus 2. I can rearrange this thing so that I've got du is equal to 1 over x plus 2 dx. And that looks a lot like that part of the integral that we're working with, right? And so I'm going to substitute. I'm going to make my substitution. And I'm going to replace this with du. And so I get the integral of u du. That's neat. What's the integral of that? Well, it looks just like a power function. So I'm going to treat it like a power function. And when I integrate, I've got 1/2, right? That's this half out here, multiplied by u squared, adding 1 to the exponent, divided by 2, which is equal to, well, maybe I'll just rewrite this as u squared over 4. Now I want to replace my u with this thing, what I defined it as earlier, log of x plus squared. So I'm going to have log x plus squared, and that whole thing is going to be squared and divided by 4. And of course, plus my constant term, lest I forget. Now looking at this thing, the integral of that is this down here, and so we're done. But let's prove it. Let's see if this is really, let's see if it's really the integral of what we were integrating. And to do that, I'm going to take the derivative with respect to x, and I get 2 times the log of x plus 2 divided by 4 multiplied by 1 over x plus 2 and we get 1/2 times the log of x plus 2 over x plus 2, which is equal to the log of x plus 2 over 2x plus 4 and that's what we started with. So we did integrate the function properly.